All right. Good afternoon, everybody. Can you guys hear me okay through the headphones? Thumbs up? Okay, awesome. Thanks everybody for coming today. I know you have lots of choices to make around Reinforce and what you're gonna do, so great to see everybody here. Let's go ahead and get started. So my name is Scott Ward. I'm a Principal Solutions Architect. I work on our External Security Services product team. So this is the team that owns GuardDuty, Macy, Detective, Inspector, and Security Hub. So I focus on working with customers to help them understand how our services work, as well as work with the engineering teams that are building the products to make sure that what they're building lines up with what customers expect and need from our security services. And I'm joined today by Sujay Doshi, who is a product manager on the GuardDuty team. And Sujay will give a little bit more intro on himself in a few minutes when he comes over and takes over from me. So today we are going to be giving you an intro to the GuardDuty Malware Protection service. This was our feature. This was announced yesterday during the keynote. And so Sujay and I are gonna take you deeper into the actual feature, let you know how it works, and then we'll give you a chance to ask questions. We'd ask is that let's try and leave questions until the end. In this type of format, it probably works best if we just kind of pop down here for questions after we're all done. Sujay and I will stick around here as long as you guys have questions and make sure that you guys have all the information that you need. So to start off with, who here today is using GuardDuty? Who has GuardDuty turned on in their accounts? Okay, got it. Just a quick overview on GuardDuty as a whole, and then we'll start getting more into the new feature perspective. So GuardDuty is our threat detection service on AWS. It's a single click enablement to enable GuardDuty, so one click or one API call, and you can turn GuardDuty on. GuardDuty is focused on continuously analyzing AWS log sources to produce findings based on threats that have been identified. And we identify threats around different resources, your Amazon S3 buckets and your objects, container workloads, instance workloads, so your EC2 instances, and then your actual accounts and the users. So thinking about principals or unauthorized principals who are actually interacting with your accounts and your resources. So all these detections and these findings result in high, medium, or low severity findings that are there for you in the GuardDuty console, or through the GuardDuty APIs, or through EventBridge, for you to be able to actually consume them and figure out what you're going to do next for these identified threats. And this is all focused on allowing you to take action. So we're surfacing up this information that we've observed from the AWS platform based on your resources, and giving you information so that you can begin to respond to and ultimately remediate a threat. So a little bit more on how GuardDuty works. And so what I'm going to highlight here is everything around how GuardDuty works except for the malware protection, because we're going to highlight that next. But at a high level, so GuardDuty works on 5 different data sources today. VPC flow logs, DNS query logs. These are queries, outbound queries out of the Amazon AWS DNS query hosts, AWS CloudTrail events, S3 data plane events, and then EKS control plane. That's the EKS audit logs feature that we announced a few months ago. So all of these data sources are continuously ingested into GuardDuty. You do not have to turn them on in order to get value out of them. GuardDuty is directly connected to automatically receive all of these log files as soon as you turn on the service at whatever scale. So like, for example, the EKS audit logs, if you have 1 cluster, if you have 100 clusters, GuardDuty will consume all the audit log information for all those clusters for the life of those clusters. So you really just focus on turning on GuardDuty and getting value out of it. With all of this data, GuardDuty is going to produce 2 different kinds of detections. One, we're focused on threat intelligence. So we get threat intelligence from 2 of our partners, CrowdStrike and Proofpoint, as well as we have threat intelligence generated by our own internal threat intelligence teams that are working through researching what we're seeing based on the AWS and the Amazon platform. And so we will be able to detect and report on things like Bitcoin mining or communication with a known bad command and control server. But we also have another section that's focused on anomaly detection. This is using our machine learning algorithms, and these are intended to detect unusual or suspicious activity that we've observed in your accounts. And so GuardDuty is going to learn how your account normally operates for a bit of time, and then be able to detect these anomalies. So we'll be looking for things like suspicious access patterns, looking for ports being used that are not normally used in your environments, or a specific type of instance being launched, or an unusual volume of EC2 instances being launched, or an unusual volume of S3 objects being retrieved. These are all items that could be anomaly detections that would result in findings in GuardDuty. So these will result in a high, medium, or low finding based on the type of threat that we've observed. And then you can use the GuardDuty console to be able to view these findings. You can also go to the Amazon Detective Service to do more investigation based on those findings. If you have Security Hub turned on, these GuardDuty findings will automatically flow into Security Hub for you to see. And then GuardDuty sends a copy of every one of its findings off to Amazon EventBridge as well. So you can use that to build EventBridge rules and route any rules that match the rule you've defined onto a target. That could be simple as like a Lambda function or a step function. It could be to another AWS service such as SNS or Lambda that might actually send it on to a partner as well if you're using some sort of a SIM or a ticketing tool to actually consume and help you give visibility around those findings. So that's how GuardDuty works today. Let's talk a little bit about the problem statement. Why did we pursue a malware detection service, and why did we invest our time in building this feature out? So malware has existed for quite a while. It's there. It's intended to be able to compromise workloads, repurpose your resources for malicious use, and gain unauthorized access to your data. They can often disguise themselves as what look like legitimate files, and then they can proliferate themselves throughout your environment without you ever detecting it. Attackers often leverage these files to then gain access to your resources or exfiltrate data. Ransomware and Bitcoin mining are the two of the more popular types of ransomware that we're seeing out there today. And so to fight this, customers have often deployed software solutions to be able to prevent and detect malware, and that's often been deployed in the form of agents. Now, with the cloud and the value prop that the cloud offers, customers are taking advantage of the self-service aspect, the pay-as-you-go aspect, and the ability to dynamically scale up and down your resources. And this has resulted in some very different and dynamic application architectures and deployments that has resulted in a lot more resources spread across a lot more accounts and a lot more regions. And when you look at containers coming into the picture, that's even gotten bigger. The ability to deploy many containers across many resources, across many regions and many accounts. So a lot more of everything is being used with the advent of the cloud and the advent of the new technologies that customers can build their applications on. On top of that, when you think about container technology specifically, there has now been introduced this another abstraction layer between the actual compute infrastructure and the container itself. And it's proved a little bit challenging to be able to identify and detect malware that's happening on container-based environments. And so with some of these challenges and the large number of resources that these new application workloads are showing, customers have at times chosen not to deploy malware solutions for these particular use cases, or they've kind of come up with some piecemeal solutions in order to be able to try and fill the gaps and accomplish their security goals. And what this has meant is that from a security team perspective, they've had a hard time keeping up with the business. They haven't been able to properly keep up with the scale that the business is running at and be able to properly secure all the resources that they have. Sorry. So that's everything I just said. So this led to the question that we get from our customers of how can I detect malware on my AWS compute workloads? So with that, we came up with the GuardDuty malware protection feature of GuardDuty. It's delivering agentless detection of malware on your AWS workloads. And so some key features of this particular part of GuardDuty: single-click enablement. Malware protection is an additional feature of GuardDuty. You just need to come in, enable that particular feature, accept the new service link role, which we'll talk about in a few minutes, and you now have the malware protection feature enabled. So you could do that for every one of your GuardDuty accounts. You can do it one time from the delegated administrator account. So because of GuardDuty's integration with AWS organizations and the fact that you can consolidate all of your findings from all your organizational accounts up into one account, you have the ability for more centralized monitoring. So not only can you see your GuardDuty findings, you can now see the malware detection findings that are going to give you more insight into what's happening on your compute workloads, you're going to get more context. So if GuardDuty is reporting that there's suspicious behavior happening, you now have these malware-related findings that are going to give you more context on what might be the source of that suspicious behavior that the GuardDuty service observed. This is all agentless. All you need to do is turn the feature on in GuardDuty, and the service takes care of the rest to be able to capture the resources and do the malware detections and report that back as findings. You don't have to install any other software or install any other agents on your compute resources in order for this to work. It's container aware. So we are looking at your EC2 compute workloads, but when we detect malware, we are detecting it at the container level. So we can report back to you which containers and on which, if it's running on a different AWS service, such as ECS or EKS, what's the configuration of the cluster that particular container is related to. And there's no performance impact here. So we are not running these malware scans on your compute resources. We're running these scans in a GuardDuty service team account, so you're not impacted at all while these malware scans are happening. And there's no hidden costs for that scanning. We'll highlight the pricing here in a minute. We have very clear upfront pay-as-you-go pricing for this particular feature. Okay, so with that, I'm gonna turn it over to Sujay for a little bit, and I'll be back more to talk about operationalization of the malware service.
All right. Can you guys hear me fine? Perfect. Thank you, Scott, for really introducing on what this feature is. Good afternoon, everyone. My name is Sujay Doshi. I'm a senior product manager with Amazon GuardDuty. I hope you're all having great time so far at Inforce over the last 1.5 days. All right. Now that we established on what GuardDuty malware protection as a feature is, let's try to understand the rationale on why we really built this. For that, let's closely look at the modern day application deployment that happens in cloud. That includes hundreds or thousands of resources, and in case of containers that have become very prevalent in today's application development and deployment, there can be millions of resources across hundreds or thousands of accounts. If we are to apply the traditional security methodologies of using the agents on all of these resources, it comes with its own cost overhead, performance overhead, and in some cases, it can also be the put application availability at risk. What if the malware compromises the agents themselves? In this case, we can put the enterprise at the risk of completely disabling or disrupting their protection, and that's a blind side. And as Scott mentioned around the layers of abstraction that the container technology introduces, without incurring the operational overhead, one cannot just have the adequate security coverage if you are to use the agents. And as a result of this, the customers who decide to completely not enable malware protection or use multiple disparate solutions in order to get this adequate security coverage, all of this is inefficient. So, and also let's have one more example around the current state of GuardDuty findings that we have. So I'll take example of two different findings that's actually related from the same GuardDuty account. So we see on the left you see a Kubernetes API that was called suspiciously from the anonymous user. The system tags this to be used by the attackers in the discovery tactic, and essentially it results because of a misconfiguration of the EKS cluster. From the same account in GuardDuty, almost 1 hour apart, we see on that EC2 instance, there is communication that's happening outbound to a known Bitcoin mining IP address. And as you can notice, there's a Kubernetes cluster, the EKS cluster that's running on this EC2 instance. Now, looking at these findings, and I'm sure people in the crowd using GuardDuty, some of these questions might be relatable. But when we talk to our customers, the questions that came to their mind were, was this instance compromised? Is the workload that's actually running on this instance that is compromised? Is there a malware that got downloaded because there is some communication that's happening outbound and by a drive-by download that there's a malware that got downloaded? Or was there a malware that's already present in the workload or the EC2 instance that's initiating this communication outbound? Exactly to help address all of these questions. And by the way, our customers, in order to get this answer, today they used to kind of just download these findings by exporting them from GuardDuty or sending it to some downstream systems, and then going to multiple disparate solutions to actually find the source of this malicious network communication. So to address that, we built this feature to really help you find the source of malicious network communication that's happening from your EC2 instances or container workloads. Also detect threats, as we established that containers are a key part of the application development and deployment that happens in cloud. So help detect the threats that originate from container compromise. And also the additional context, as we'll see in the findings that we'll walk through in the course of this presentation, the additional context that's added to the findings will really help the analysts to contain the threat without having to go to multiple solutions. Mean time to respond, again, is a critical component in investigation and security today, wherein that has to be lower in order to contain the threat. And this helps achieve that. So from a coverage standpoint, the feature will help detect malware on EC2 instances. If there's an ECS cluster that's running on the EC2 instances, EKS cluster if that's running on EC2 instances, or even customer managed Kubernetes, Docker, container, container that's running on EC2 instances. So when is it that GuardDuty initiates a malware scan? So as we saw in the previous slides, the reason we built this feature is we wanted to help you initiate and find the answers for the malicious network communication that we saw. So essentially, whenever there is a GuardDuty EC2 finding, because we are monitoring the VPC flow and DNS data, so whenever we see an EC2 finding that indicates some suspicious outbound communication, the system, if the feature is enabled, the system initiates a malware scan. And we'll see in a bit on the findings that initiates malware scan out of the box. One important thing to notice is it's not that we'll always scan whenever there is an EC2 finding. The guardrail that we have added is this will only scan the EC2 instance once every 24 hours. And there are a couple of reasons for this. The scan is an expensive operation, so we do not always want to initiate a scan if, let's say, every 15 minutes I see a GuardDuty finding. It may be a same finding or a different finding on an EC2 instance, because most likelihood, it's the same malware alert that would get generated, right? So we do not want to kind of just inundate you with all the same malware alerts and increase your alert volume so that you're not prioritizing the alerts that matter. So that's one of the key points in which we won't initiate a scan within 24 hours. So these are the list of EC2 findings that will initiate a malware scan. We have like 29 finding types out of all the different GuardDuty findings that we have today. If you look at the list, pretty much all of them indicate some potential compromise that would have been observed on EC2 instance that's initiating this communication outbound. We see C2 communication, drive-by source traffic communication, DNS data exfiltration, DGA, phishing, so on and so forth. And you can always refer the GuardDuty documentation for up-to-date list in case of when we add new findings. So to summarize, the benefits of using this feature within GuardDuty is it helps you protect the unprotected EC2 instances. Because again, if you have an EPP strategy, that is the endpoint protection strategy, or an EDR vendor that's providing agents, it's not that all your EC2 instances will have the agents. Or even in the case we talked about the containers, with all the million resources, you might not always be having the agents on it to get the visibility. So this feature, because this is an agentless approach, it will help you have this visibility without having the agents. The container awareness, as we talked, really is key to this, in which you'd be able to initiate your remediation workflows by actually pointing to the true source of infection, as opposed to taking generic actions of such as isolating the whole instance and not just the workload. And having a single source for the GuardDuty findings, that is the network anomaly findings, and the malware findings provides that level of correlation within the same console, or even if you are consuming the findings downstream to some other system, provides that level of context to initiate the right remediation workflows without, again, having to go to multiple different solutions. All right, so let's talk about how really this works under the hood. So I'll take an example that you have a GuardDuty deployment, let's say in a region A, and there is a finding on EC2 instances. Let's make some assumptions at this point, or not assumptions really, but the true example as you see, right? The EC2 finding of the EBS volumes that's attached to the EC2 findings, they're encrypted using your KMS key. So when there is an EC2 finding that's observed on the GuardDuty, and the feature is enabled, the system takes snapshot of the volume that's attached to the EC2 instance. It attaches a snapshot ID when it finds the EC2 instance that's having this suspicious communication. And I'll touch upon the service link role in a minute. So that's very critical to the overall permissions that's allowed to this feature. But once there is a snapshot that gets created in customer account, in GuardDuty service account, essentially there is a replica volume that gets created from this snapshot so that we can run our scanner using our compute. What happens after that is there will be a disposition based upon the malware scanner that's run. It comes out whether a threat is found or not. And if there is a threat that's detected, there is a finding that gets generated similar to any other GuardDuty finding that we have. And we send it to the GuardDuty console for the customers to consume. What happens after this? There's some, we delete the snapshot because the scan is completed and we have a result. We also delete the replica volume. We do not want to keep customer data in our account. So a very key component of all of this, because security is kind of a top priority always for everything that we build at AWS, right? So as a result of this, because this feature interacts with the customer data, and it's kind of permissive in terms of what we are reading, we wanted to build a service linked role that you would enable at the time of enabling the feature, and it gets attached to your account. That service linked role specifically has provisions which allows sharing these KMS keys and specific operations that's related to kind of decrypting and re-encrypting to create the replica volume. There are specific functions that's only allowed at the time when the scan is run. So it's not that we'll always have access to your keys once you accept the role and you enable the feature. The access to the keys will only be for the period, the grant essentially will only be for the period when we are kind of running the scan engine. And once we delete the snapshot, we come out with the results, the grant is revoked. So all of that is bundled within the SLR in which indefinitely we would not have access to either your snapshot, volumes, or even the KMS key. The other interesting thing to note here is you might be using the same KMS key for multiple different things, such as DynamoDB tables that you're encrypting might be with the same KMS key that you're using here to encrypt your EBS volumes. The interesting part here is, even though we have access to the KMS key, it's only in the context of the operations by the EBS service the key can be leveraged. So today, no user of GuardDuty having the access to this key can go to your DynamoDB table and decrypt the data. It's only relevant in the context of the EBS service, which kind of calls, create snapshot, and we'll look at the actions such as this, which calls create snapshots, create KMS grant, and essentially all the cryptographic functions of decrypting and re-encrypting from. That's a very key aspect in which we did not want to really have the keys to the kingdom in a sense and kind of use it anywhere. You revoke the grant once the operation is finished. So let's look at some of the key components part of the service link role. The first three are pretty much sort of the discovery side of it, in which before we initiate the snapshot creation and creating the replica volume is where we'll kind of describe the EC2 instances or the volumes. Because today we support only volumes that are less than a terabyte. If a volume is above a terabyte, upfront we'll just not kind of perform the scan so that we are not charging you by scanning and then discovering. So the first three permissions will allow to do this. Then we create snapshots. So now a customer might have multiple snapshots for whatever reasons. It is not that because we have the option to create a replica volume in GuardDuty service account, we'll just be able to use any snapshot. It absolutely needs to have a scan ID, which we saw in the previous how it works diagram, that gets attached every time there is the feature enabled and the GuardDuty EC2 finding is observed. So even if you might have some 100 other snapshots, we cannot create any random replica volume. We always can create replica volume from the snapshot having the scan ID. You can create tags only when you're creating a snapshot, and we'll discuss about that in a bit. Modification of snapshot again helps to share it with GuardDuty service account. So you modify the attributes so that you can share it with GuardDuty service account to create the replica volume. An interesting thing over there is you cannot modify the snapshot attributes to make it public. So that's a deny rule that's added to the role, which will make sure that you accidentally the service does not make the customer data public. We discussed the KMS key grant, which basically allows the decryption and kind of re-encrypting the volume when the replica volume is created in GuardDuty service account. And also the code, there might be some volumes in customer account that are not encrypted. In that case, we'll use GuardDuty's KMS key to encrypt it. So essentially, always your data, either in your account or our account, will always be encrypted. Or at least when we are running and we are accessing the data, it's always encrypted. The volumes are never unencrypted. And that's it from a very important thing. There is a super tag, I like to call this a super tag, called as GuardDuty excluded tag. If you have marked your resources, that is the volumes, the snapshots, the KMS key, with this tag, it essentially means that you're not allowing the system to touch those resources. So it would not be included in any operation. So if you have some sensitive data that's residing that you do not want the malware scanner to kind of run and detect or access that data, essentially, you can have a super tag that says GuardDuty excluded, and that's it. We would not be touching that or creating a snapshot and perform any operation. And that can be true for even your KMS keys. So this is a list of all the different file systems that we support, essentially the volumes that are formatted with these file systems, and covers major Windows and Linux distributions. And again, you can always refer to the GuardDuty documentation for the up-to-date list when we add new file system support in future. There are some customization options that we have provided to the default setting. The default setting is, as we discussed, we always delete the snapshot as well as the replica volume once the scan finishes. But there is one requirement that actually came from customers when we showed this is, can we retain the snapshots wherein there is a malware that's observed? Because typically, you might have some investigation workflow and you would need for forensics the snapshots, right? So we have provided an option in which you can decide to retain the scanned snapshot that has a malware. So that way we won't just delete that, and we'll kind of tag it with a different GuardDuty finding detected key. The snapshot costs apply as it is with the EBS service storage, right? So if you're retaining the snapshots for some time period, whatever charge that the EBS service gives, that's prorated to however long you retain it. There are some other options such as exclusion and inclusion, and this is very important in terms of controlling the costs. You can really decide on how or which instances you want the feature to kind of run the scan on. But remember, the GuardDuty excluded tag kind of supersedes any inclusion or exclusion. So even if you have an inclusion tag that will have list of all your instances that you can scan, but one of that instance has GuardDuty excluded, essentially that would not be touched. So the idea here is that we do not want customers, they were concerned in terms of what if there is scan that initiates on all their EC2 instances where there is a finding. Can they control only on specific sets such as prod and not do it on dev or QA? Then you can do that using the inclusion and exclusion tag, and this is how you provide, you can select one of the two. You can say that either go with a list of all inclusion or exclusion, and you can add the key and the values are optional. Let's talk about pricing, and I'll start with the free stuff, because why not, right? There's a 30-day free trial similar to all the protection plans that we have, the other protection plans that we have in GuardDuty, wherein you can enable the feature. So if you're a new customer of GuardDuty altogether, this feature will be enabled by default, but you can decide to kind of, but the first 30 days will be your free trial. Or if you're an existing GuardDuty customer, you can essentially decide to opt in. And there's where your 30-day free trial starts. Here, based on your EC2 finding, the scan initiates, and then if there is a malware finding that's detected, it will be routed to your GuardDuty console. It's 3 cents, so the pricing is pretty straightforward in a way. We charge 3 cents per gigabyte of volume, or the data in the volume that we scan. And the pricing will depend, obviously, in the region in which you have the deployment. But this is pretty much common across at least the North America regions. And if you are retaining the snapshots, then that costs are prorated during the life of the snapshot as per the pricing model with the EBS service. Like we established, the EBS volumes over a terabyte will not be scanned, which means you would not be charged. Even if there's an EC2 finding, the system automatically will not consider those volumes. Today, we only support encrypted volumes that are encrypted using the customer KMS key. We do not support the volumes that are encrypted with the EBS managed keys. And the first 3 rules in the SLR essentially helps deduce all of that. Let's talk about partners. So we have these partners who integrated with GuardDuty Malware Protection, and essentially what some of the use cases that they solved is enrichment and correlation. So in their data lake or XDR or call whatever central console that they are getting all this data, they collected GuardDuty malware findings and provided a mechanism to the common customers who's using GuardDuty and one of this solution, more information in cases where there's no agent that's installed on it. Also, some of the partners went ahead and actually built some remediation workflows, such as having a Lambda function, get the information of whether an agent is present. If yes, collect in-memory data and push it to S3 for forensics. So that's also a remediation step that was added by a few vendors. We're using Bitdefender in addition to the integration partners. We're also using them as the technology partner in addition to the internal ML models that we have. We are using their anti-malware engine. So I'll hand it over to Scott, who can then walk us through how you can operationalize the findings and really monitor of what's happening under the hood. Thank you.
Thanks, CJ. Okay, everybody. Perfect. Let's talk a little bit more about the information that the Malware Protection Service is actually going to give you and how you can actually use that and get some information out of it and be able to make a decision. So to start with, got 2 findings here. The one on the left is an EC2 related finding. Remember from Sujay's discussion, an EC2 related finding is what's going to trigger a malware scan to happen. So on the left, we have an EC2 related finding where we've actually found cryptocurrency mining occurring and reaching out to a Bitcoin mining tool. And on the right-hand side, we have an indicator that a malicious file was found. So some information you're going to get on that malicious file finding. First thing, on the bottom right, we're going to tell you the threats detected. Actually tell you what are the malware files that we found and what's the location of that malware file on your EC2 instance. You will also notice that on the left-hand side, we're reporting which instance this is for, and on the right-hand side, we're reporting that that's that same instance. So you have those to be able to correlate against to get a stronger signal that what happened on the left may be attributed to what was found on the right. If we dig a little bit deeper into those findings, we also have the ability for you to actually correlate based on the finding ID itself. So every GuardDuty finding has a unique finding ID, which is what you see in the top left here. And then on the malware scan related finding, we'll actually give you a field called the triggering finding ID. And you can match that up to the specific EC2 related GuardDuty finding that triggered the malware scan that produced another finding in your GuardDuty account. So if you're ever looking at a malware related finding, you're looking at triggering finding ID. If you're in the console, you can actually click on that little plus sign next to the finding ID on the right, and we'll actually put it into the search bar, and it will bring up the other EC2 related finding that is attributed to that malware scan finding as well. So it's a way for you to get more context around what's happening in your environments. And then we talked about the fact that this service is container aware. So running on EC2 with ECS, EKS, or your own customer managed container deployments will not only produce you a malware-related finding, but will give you the context around the containers. This is an example from an ECS cluster, where we not only tell you that it's a cluster, we tell you the name of the cluster, we talk about the tasks, we talk about the containers that this malware was related to. So it allows you to, from an investigation and a taking action standpoint, to be able to get down to the exact resource and the exact container that this is related to, so that you can go out and terminate it, fix it, patch it, remediate it, isolate it, whatever you want to do as part of your particular workflow. So what can you do with the malware findings? So we've shown you that we give you an EC2 related finding, we give you a corresponding malware related finding. What can you do with this information? Well, the first thing is that you can send this to Security Hub. So if you have Security Hub turned on and you have GuardDuty turned on, all of your findings from GuardDuty will automatically flow into Security Hub. And the same thing applies to these malware related findings. Those will automatically start showing up in Security Hub. So right away you have information around EC2 related findings as well as malware related findings for the same resource. If you have other security related findings coming into Security Hub for that same resource, whether they be security standards checks, whether they be findings from a third party, you'll have the ability to aggregate and be able to see a larger view of what's happening for that particular resource, which might even give you a stronger signal around how much you need to prioritize taking action against that particular EC2 instance or the container. Amazon Detective, as well as Security Hub, integrates with EventBridge. A copy of every finding that those services generate is sent to EventBridge. And you can actually author an EventBridge rule with a specific profile that is looking for all GuardDuty findings. You can go very specific. You can go to very specific finding types. If you're looking for just the malware-related findings, you can use the EventBridge integration to trigger an action. You can send that rule onto 20 plus AWS targets, which would allow you to send it via email. You could send it off to a ticketing tool, a chatbot tool, whatever works best for you, but you can leverage the information in those findings to trigger a specific response within your security teams. Amazon Detective. If you're using Amazon Detective, there's native integration between Detective and GuardDuty. All GuardDuty findings flow into Amazon Detective. And so you can use Detective as a way to investigate further what's happening on that particular resource that the malware was found. You can look at the time series graphs of network activity or API activity against that. If it's a Kubernetes cluster, Detective for EKS yesterday announced support for EKS audit logs. You can investigate more into the actual EKS API control plane calls that were made against your EKS cluster related to malware findings that were reported on that same instance that's hosting your EKS cluster. This can also just be a starting point for a deeper investigation. Customers want to know, understand more of like how that malware got there. So you could start by maybe terminating that infrastructure, maybe launching something fresh, but you also might want to do a deeper log dive to investigate further, like how did this actually happen? You might want to actually do some disk forensics. It might mean that you actually want to have your own copy of that EBS snapshot that you might mount to a security instance that has the right forensics tools in place to figure out more of what did this actually do. You might want to investigate more of what was the impact of this malware. Yes, it's running on this EC2 instance, but where did it come from? Has it actually spread somewhere else that we need to investigate further? And then think about what are the preventative controls. If you identify how did this malware get on here in the first place, there might be a need for some additional controls that prevent this from happening the next time. So these findings can give you a stronger signal that there's a problem on your EC2 instance and help trigger what that deeper investigation and ultimate remediation might look like. So earlier, Sujay showed you how everything worked end-to-end between the customer account and the GuardDuty service account. The key thing I want to point out here is that you can track through CloudTrail evidence of what's happening as we proceed through the process of snapshotting your volumes and detecting the malware. So you're going to see that we are creating the snapshot. You're going to see this as a call coming from the GuardDuty service. You're going to see that we're re-encrypting the data so that we can look at it on our side as we attach these snapshots to an EBS volume. You're going to see us modifying the snapshot attribute so that we can share that snapshot with our account. You're going to see us creating a grant so that we can actually add some encryption context to the EBS key on our side. And you're going to see us deleting the snapshot. So you're going to be able to see that life cycle of us interacting with your resources in CloudTrail to help validate and know where that activity is coming from or who's the particular service that's interacting with your resources if you're doing a CloudTrail investigation. We also give you evidence in CloudWatch logs. So every time the malware service starts a scan, we will log to CloudWatch that we have started the scan, as well as all the different details about that particular scan, what resource it was for, which EBS volumes that particular scan was for. We will also log when we found threats. So in this case, you can see that we've got the EC2 scan is completed, and we're indicating that we found threats. We're also giving you an insight on how much data we had to scan and how many files that comprised, as well as the EBS volume and the EC2 instance that was related to. And then finally, even if we didn't find any threats, we'll still tell you that the scan completed and that the volume came out clean. So what this allows you to do is if you got an EC2 related finding in GuardDuty and you're like, oh, I don't see, this seems like it would be attributed to malware, but I don't see a malware related finding, you can use the CloudWatch logs to be able to verify that a scan completed and that it came back clean. So this can be another part of your overall investigation, or if you're collecting data to facilitate what you're going to do next, the information that's in CloudWatch logs can be valuable to you as well. So the next thing I want to highlight, this malware protection feature delivers you a lot of value and it gives you a lot of ability to cover a lot of resources in your AWS environments and your accounts. This is not intended to be a direct replacement for a cloud workload protection or an endpoint protection solution. There's some key attributes that those solutions provide that the malware protection feature does not have today. We can't scan and detect as soon as a file hits your file system. We're not an agent running on your compute resources. So we aren't able to track system behaviors because we're not in line watching what's actually happening. And we don't quarantine or remediate the threats. So there are things that those types of solutions do that you may still want, or just to make clear that you're not getting from the malware protection service. So there's still a place and a time for those. But even if you're using those services, those solutions today, you have licenses and you use them in a lot of places, there's still a use case for the malware protection service. So one, the malware protection service may give you a peace of mind. We may actually catch things that the endpoint solution has missed. We may find something that's actually written on the disk that the endpoint system didn't see. It's a single source of findings. So both the EC2 related network findings as well as the malware findings, those are all in one place in GuardDuty, and you can easily correlate those and see them together. We can cover instances where you haven't deployed a cloud workload protection or an endpoint protection solution, whether it's cost prohibitive to have an agent in every place. The infrastructure is too dynamic for you to be able to take time to get the agents deployed on there, or somebody just didn't deploy in the first place. And then we can, potentially, we're in a position to be able to find malware that's trying to evade the agent during runtime. So all opportunities to still take advantage of the malware protection service. So the next thing I'd like to highlight here is GuardDuty testing tools. So we have customers who want to see all the goodness of GuardDuty, but GuardDuty is detecting threats. And so ideally you turn on GuardDuty and there's nothing there because you have no threats in your environment, but you want to still be able to see those findings against actual infrastructure and resources in your environment so you can figure out how you're going to operationalize them and respond to them. So we have an open source repository called the GuardDuty tester that now has been updated to support the malware protection feature. So the way that this works is that you will launch a CloudFormation template into your account. It will create an ECS cluster, as well as a couple of target EC2 instances, one Linux and one Windows. You will then log in SSH into the ECS cluster, run a small script that will perform various malicious commands against that infrastructure that was launched. We also stage some sample ICAR malware files. So these have malicious looking strings, but they are not malicious files. And what that will result in is that GuardDuty will generate EC2 related findings. And based on that, we'll then go and actually do a malware scan on that ECS cluster. And you'll get back findings both at the EC2 level reporting malware files, as well as an ECS related finding that reports back the malware files. So this is a great way for you to go in, turn on the tool, and actually run it and test it and see some of the results without sitting and waiting for malware to actually show up on your environment. Okay, so with that said, first of all, Suji and I'd really thank you for coming out. Once again, you have a lot of things you can be doing. We're very happy to be able to share our info with you. Please make sure you fill out the survey. Tell us what you like, tell us what you didn't like. Let us know what questions you have that you want us to cover in the future. We read all that feedback. And then Suja and I will just pop down here to the side. And any questions you have, come on down and we'll give you as much of our time as you guys need. Okay. Thanks for your time.